Hello everyone, it's Miss Prissy again and back for another episode of Solving Equations 1.7. Okay, an equation is a number sentence. An equation is going to have an equal sign in it. A solution is the answer, is the value of the variable that makes the equation true. Now, I'm not going to read all these different properties to you, because you've had them over and over again. If you would like to write them down, remember that you can pause the recording, write them down, and then continue. So we're going to go on to solving equations because we're in the big boy leagues. This is Algebra 2, remember, so this is a review. Okay, so solving equations with variables on one side. I love doing these things, okay? We need to get this x by itself, all by itself. So I'm going to draw a line down the equal sign. I guess I should have done it in blue because I usually call it the river, okay? Kind of like in Texas Hold'em, usually call it the river. And we have to get rid of everything around the x. We clear addition and subtraction first, then we clear multiplication and division, okay? So I've got to get x by itself. In order to move the 7 to the other side, I have to do the opposite because we need to get rid of it. So the opposite of adding 7 is subtracting 7. And I draw a line because that's a Miss Prissy thing. I show all my work, do all my steps, and then all I do is add straight down. So 2x plus nothing, well that's 2x. Plus 7 minus 7, they go away. I still have my equal sign on the river. 1 minus 7 is negative 6. Now, what operation is going on with that 2 and the x? I know y'all are going, multiply, multiply, multiply. The opposite of multiply is to divide. And whatever I do to one side, I have to do to the other. I know y'all have heard that over and over and over again. So we cross those out and we get x. Sorry about that. That was Madam Barks a lot. And we get negative 6 divided by 2, which is negative 3. So before I can put a box around it, I have to figure out whether or not that answer is correct. So I'm going to play my favorite game in the whole wide world, plug and chug. And you're like, but wait, where's the x? Well, instead of putting in x, I'm going to put in the number. Remember, every time I take an x out, I put parentheses in its place. And what am I going to fill in its place? I'm going to fill in the negative 3, which is our answer. So let's see if it works. And we reviewed order of operations in the last lesson. So this becomes negative 6 plus 1. I'm sorry, plus 7. Negative 6 plus 7 equals 1. Well, negative 6 plus 7, that's 1. And 1 equals 1, so that is true. So now that we have proven that our answer is correct, we can put a box around it. And on to the next page we go. Oh, but what happens if we have variables on both sides? Well, we need to simplify first. Okay? So we're going to take our distributor property, and everybody's going to get the one side. So we wind up getting 1/2 n minus 1/2 times 4. And this negative 3 here, and the negative 3 goes there, and we get negative 3 times 2n plus a negative 3 times 1. So we'll simplify, and I'll get 1/2 n minus, and before y'all start having a heart attack with the fraction, just read this as a problem in words. 1/2 of 4. Oh, that's easy. That's 2. Negative 3 times 2n, negative 6n. Negative 3 times 1 is negative 1. And instead of writing plus minus, I'm just going to write that. So negative 3 times 1 is negative 3. I'm sorry if I said plus 1. Okay, so now what do? We've got letters on both sides. My rule of thumb, let's do our river, My rule of thumb is always move the smaller number to the bigger number. Smaller in value. So negative 6n is smaller than 1/2. So I'm going to make this plus 6n. Why plus 6? Because it is the opposite. And I draw my line, and then I add straight down. And 6 plus 1/2 is 6 and 1/2 n minus 2. These go away, minus 3. So then what? Well, we got to get rid, now we're going to get the numbers together. Get letters on one side, numbers on the other. Letters on one side, numbers on the other. So now that our letters are together, we've got to work on our numbers. 6 and 1/2 n equals negative 1. So I'm going to go and draw a little line up here because I'm running out of space. So 6 1/2 n equals negative 1. You're like, oh my gosh, how do I do that? Well, this is, don't forget your 6th grade math. 6 times 2 plus 1, what is that? 13 over 2 n equals negative 1. And how do we get rid of this fraction in front? Okay, remember guys, this is the big leagues. We can multiply by the reciprocal. So we'll multiply this side by the same thing. These go away and I wind up getting n. And on this side, I'll get negative 1 times 2 over 13. Which becomes, I know it's all over the page here, negative 2 over 13. Boom, presto, magic. Now, I would like for you to go back and check, but I understand if you don't because we're running out of space. Next frame. Types of equations. We have a conditional statement. It's true for some values, but not for others. An identity is when it's true for any number that we put in. A contradiction is when it's never true. So I want you to think of a contradiction as no solution. I guess I should put. An identity is infinitely many solutions. That means that it can be any number that you put in. So let's start with example number 3. We're going to consolidate to make it look a little easier. We're going to combine our like terms. 5w and a negative 4w is w. So we're going to get w plus 8 equals w plus 2. Okay, the rule is letters on one side, numbers on the other. Okay, so I'm going to subtract w from each side, draw my line, and I get 8 because the w's go away. Oh, but wait, our w's go away there too. And I get 8 equals 2. Is that true? Does 8 equal 2? If I have $8, does that mean I still have the same if I had $2? No. So this is a contradiction. Or no solution. That no matter what number I pick for w, it will never work. Okay, so let's try the other side. And you're like, oh my gosh, it's all fractions, fractions, fractions. I'm going to show you the coolest way ever. Okay? Coolest way ever. You got to be paying attention. Everybody's got to be paying attention. Hope you have your listening ears on. The coolest way ever to find out how to solve this problem. Watch what I'm going to do. What is the common denominator? Everybody should be going, 6, 6, 6. Yes, it's 6. Okay. 6 times 3, I'm sorry, not times, divided. 6 divided by 3 is 2. So I wind up getting 2x. 6 divided by 6 is 1. So I get 1x. 6 divided by 2 is 3, so I get 3x. So now let's solve. I get 3x on this side equals 3x on this side. Well, let's go ahead and divide by 3 on each side. And I get x equals x. So what does this mean? This means it's an identity. Why? Because no matter what value of x I put in, it's always, always, always going to work. You're going to see this come up quite a bit when we do systems of equations. Okay, so let's talk about restricted domains. Domains are the values that we can put in. I know y'all are going to say, well, domain is the x value. Well, domain is not necessarily the x. It's whatever the variable is. If there's only one variable, then that's the variable that it is. Okay, so it says the domain of a variable is a set of allowable values. That means that we can only allow certain variables. Certain numbers for the variables. So in this case, the x is an element of z. And remember, z stands for the set of integers. Now, why it's a z, I have no idea. I'm sure it has something to go back to Latin. But integers are z. So our answer has to be an integer. Okay, so let's see what we're going to, oops, I don't know what I was doing. So let's go back and see what, oh, I know what I'm doing. My board is slanted. There we go. That's a little bit better. Okay, now remember what I said. Take the smaller letter to the bigger letter. So I'm going to take minus 2x away from each side because they're smaller. I'm going to add straight down. These go away and I get 5 equals 2x minus 8. Well, then I'm going to add 8 to each side and add straight down again. Add, and this gives me 13 equals 2x. Now, I'm going to divide by 2, and I get x equals 13 divided by 2. Is that an integer? Is that an integer? No, it's not an integer. So that means there is no solution in this domain. That just means that our answer is not an integer, okay? Because we restricted it to just the set of integers, but there's no answer that becomes an integer. Okay, so let's take all of that information and see how we're going to use it in an application problem. Kimber arrives at the amusement park with $50. Admission is $20. And she plays several midway games that cost $2.50 each. Wow, that's expensive. At the end of the day, she has spent all of her money. How many games did she play? So we're going to let G be the unknown number of games. And G is going to be W, which is a whole number. Now, why would it be a whole number? Think about why we're going to restrict these to whole numbers and not integers. Can she play a negative number of games? No. Can she play 0 games? Well, she could play 0 games, but then she wouldn't have spent all her money if she played 0. So that's why, and it's possible, which is, it is a whole number. But we already know our answer is not going to be 0, but it could be a whole number. And the only difference between whole number and counting numbers is the 0. So let's write an equation. Okay, so we know that she has $50 total. So whatever it's going to be, she's going to spend $50. How much did she pay to get in? Oh, she paid $20 to get in. Sorry, that's my reminders. Plus $2.50 per game. Oops, sorry. Okay, so now let's just solve our problem. I'm going to move the numbers because the letters are already by themselves. And then remember, I add straight down. So I get 2.50g equals 30. Now, what am I going to do to solve? Yes, I take 30 and divide it by 250. Now, I want you to be careful because if you put in 250 divided by 30 in your calculator, you're not going to get the right number. You have to make sure that you put it in how you see it, 30 divided by 250, and we get 12. Now, does that make sense? Is 12 a whole number? Yes. So she was able to play 12 games with her money. Well, look at that. What do we get to? We just got to the secret word. And I'm thinking the secret word is going to be Ariel. A-R-I-E-L. Ariel, as in Little Mermaid Ariel. And what do you do with that information? You write secret word on your pace chart. Why? Because if I ask you if you've seen the video, you're going to have to give me the secret word. And if you don't give me the correct secret word, then I'm going to make you go back and watch the video. And now, on to what do we do with this information? Remember, in your lesson resources, you have your reference problem set. It'll tell you what problems to do, which is your textbook, okay? It's your textbook, these pages. Do these problems. Don't let your dog eat your homework. And now for our final public service announcement. Make sure that you are putting your name and section on your communication to me. Have a good day and see you at the next recording.